Hey guys, welcome back. Last lecture we have spent just by debugging our code. In this lecture we'll continue, and this will be another additional information lecture, so another AI lecture. We'll be talking about the rotations. We have in a method compute rotation, so if you feel like you understand this code, you can simply skip this lecture and you can continue the next one, because in this lecture I'll be not implementing anything new, I'll be just explaining in details these lines of code, so I'll be sure that you will understand it. Okay, so let's start. Let's go back to Unity, and we will first get here some initial conditions. So please make sure your player, let's click on the player. It doesn't really matter when it's positioned, but the rotation is important here. It should have a rotation by the default 0, 0, 0. Now let's take a look on your cameras. Let's go to your freelook camera, and freelook camera should have a y-axis value 1 and x-axis value 0. We will change it a little bit. Let's take a look how it looks in a game view now. So when you will click at game view, you will click on the freelook camera, it looks like this. Perfect. What condition I would like to introduce here, what we would like to debug here, is when the camera is facing 45 degrees and the player is moving just purely forward. Okay? So let's meet these conditions. Let's click here on the freelook camera. Let's choose here x-axis. And let's choose here value 45, which means 45 degrees. This should rotate the camera like this. This will change also the main camera. You can click on the main camera. You don't need to change here anything, but you can notice here rotation 45 degrees. So that's why in the previous lectures we used m-axis of the camera, because m-axis of the camera is basically y-axis. So that explains a lot. Okay, so I was mentioning before to trust me that we are using m-axis, but we're using x-axis because it's basically y-axis, and now you can see why. Okay, so that's a condition, 45 degrees, and we'll be moving purely forward. All right, so we will be jumping into the debugger. So let's go to your coding editors, and let's write here if statement. So we'll be sure that we are jumping into debugger in the correct time. So let's write here if statement, debug log here. Let's write here moving, and condition will be if the move input magnitude is larger or equal to the 1. Let's save this. Now let's place a breakpoint on line 70. All right, very important. And let's attach this to Unity. So let's click here this arrow, this triangle. All right, let's attach. Okay, I can clear this from the previous lecture. And let's go back to Unity and let's run our code. So let's simply execute it. All right, and the condition is met. We should be 45 degrees. You can see, okay, we'll see here normal camera. So you can see here the camera is tilted 45 degrees. Please don't change the rotation of the camera. Just if you already rotated the camera, start over and don't rotate anything here. What you need to do only is to press the forward key. So on the keyboard, just the W key or the forward arrow. Just press it, okay? As soon as you will press it, you will go here in the compute rotation, and that's the state we would like to be in. So our move input should have a 0, 0, 1, so this means we are moving only forward. That value is 1. And now I will be drawing it for you. We'll be going over all of these methods here. Okay, so now you can basically sit comfortably, and I will be drawing. All right, or you can grab the paper or draw on the computer, and you can draw along with me. Okay, so there it is, here. Okay, so first condition, guys. Okay, so what is the first condition? The camera, I will write here, camera 45 degrees rotation. That doesn't look like a 45 degrees rotation, and the player going forward. I'll just write here arrow like up here, which means that we are moving forward. We can draw it on the also here. So let's say it doesn't really matter what the positions of the player are. So I can say the player is here on the position of 2, 2. All right. Again, top to bottom view. I don't need to repeat it, right? So this is the x-axis and this is the z-axis. All right. And the camera is behind the player. Usually the camera is here. It can be positioned. Yeah, it's positioned 2, 1, right? So 2 and 1. All right, and the camera is facing, so camera is in this 45 degrees angle. So the view of camera is something like this maybe. So that's this view of the camera. Okay, I can remove it. So the camera is facing 45 degrees, but it is not important, right? I don't need to mark it even. We know it here, the camera is 45 degrees and the player is moving forward. So player want to move here, right? So we are pressing the forward key. We should move forward, but we are not moving forward. And you will see why we will not move forward. But that's the intentional movement we would like to go here. We would like to move forward. Okay, so let's draw first thing here. Here we are saying the move input. We would like to go this forward direction. So move input is 0, 0, 1. We can draw it here. So let's say, okay, let me get it here. So this will be move input, move MI, move input. Move input, we are pressing just the forward key. So move input is going straight. Is this here? This is the move input. 0, 0, 1. Okay, so 0 for the X, 1 for the Z. So there's a forward movement. Also, there's a forward movement of the 0 on the X and 1 on the Z. All right, so now, okay, let's see. So that's a forward movement. Okay, so let's go next. I will step over here in the line. And now we'll take a look at the camera direction. So camera direction is 0 on the X, on the Y 45 degrees. You can see here the value 45. And the Z is 0. And we are multiplying with the forward vector. Okay, so we are getting here a quaternion multiplied by the forward vector. What does it mean? We will get the direction. Okay, let's show it also on the axis. Okay, so we have a camera direction. I will mark it here. So this will be our camera CD for camera direction. And camera direction is saying multiplying the rotation of 45 degrees with the forward vector. So again, forward vector, which is this one, 0, 1, multiplied by 45 degrees. This will get me new position. If I would like to rotate this 45 degrees, I would go simply here, 45 degrees. I would go here. All right. This means if you would move this vector 45 degrees, vector would be somewhere here. The vector would be somewhere here. That would be 45 degrees rotation. Remember, we need to maintain magnitude of the 1, and we need to rotate it 45 degrees. So the new positions would be somewhere here. And if we want to maintain the magnitude of the 1, and we are basically moving 45 degrees, which is a diagonal, you could already see what's happening. We should get the values of the 0.7, 0.7. So this vector here should be 0.7, 0.7, and 0.7. Oops, 0.7. Okay, so that's our camera direction, which is our forward vector multiplied with a rotation of 45 degrees. Okay, so let's see if it's the right camera direction, and the camera direction is indeed 0.7, 0.7. You can see it here, 0.7, 0.07. So we are right. Then we rotate this 45 degrees. The new camera direction will be 0.7, 0.7. Here it is. All right, perfect. Let's continue. All right, now we have here move and rotation, where we want to rotate. Again, we want to rotate from the vector tree forward into the move input. So what rotation it will create? When you think of it, let's see where is our move input. Okay, so our move input is here. Move input is here, and that's basically we are moving only forward. So our vector is 0, 1. And what's the rotation of the forward vector? Is also 0, 1. So there is no rotation at all, because the forward vector is the same as the move input vector, right? Move input is also 0, 1, and also forward vector is 0, 1. So this means that's the 0 rotation, 0 degrees. We are not rotating at all. Okay, so the 0 degrees here. So this line here, movement rotation. Okay, so movement rotation, I will actually mark it back here. So this is move input. So movement rotation, I will mark it here. Movement rotation. Movement rotation is 0 degrees, because move input is the same as the forward vector 0, 1, which means there is no rotation in between these two vectors. They are exactly the same, so 0 degrees. Let's verify this. Let's jump over this line. And move rotation is in a quaternion format is 0, 0, 0, 1. We don't really understand quaternion, so what we can simply do, we can go into intermediate window here. So you can click here view. You can search here for debug windows, immediate, and you can write here simply copy. You can even move and rotation, and here you can see Euler angles representation, and in the representation of the Euler angles, it's a 0, 0, 0. Okay, 0 rotation around the y-axis. Right? Okay, so that's the move and rotation, it's a 0 degrees. Okay, clear it out, and now we are going to target rotation, very important. So target rotation is saying here to quaternion, to log rotation of the movement rotation, which is 0 degrees, and multiplied by the camera direction. So we know that our camera, let me show it to you, our camera direction is here, it is 0.7, 0.7, which is rotation itself, 45 degrees. Okay? So 0.7, 0.7. The camera direction is 0.7, 0.7. And it's saying me here to rotate the 0.7, 0.7 vector by rotation of movement rotation, which is a 0 degrees. Okay? So, and this will look me in the new rotation. So if I have it here, this 0.7, 0.7, and I would like to rotate it 0 degrees, which means I'm not rotating it at all. Okay, so I'm staying here as I am, where I am. I don't need to rotate here anything, and I'm keeping here this 45 degrees rotation here. Okay? So this vector 0.7, 0.7 multiplied by rotation of the 0 degrees is still this rotation of the 45 degrees here, what I'm keeping. I don't need to rotate here anywhere. I'm still on the same spot, which is a 45 degrees rotation. So I can assume here that my target rotation will be in the quaternion. In the quaternion is 0, 0.4, 0, 0.9. But if I will transform it, so I will write here target rotation into intermediate window. You can see here exactly this rotation in Euler angles is a 0, 45 degrees on the y-axis, and the 0 degrees on the z-axis. So my final rotation is a 45 degrees on the y-axis. And this rotation I will assign to my player. Okay, so my movement rotation, I can mark it here. Or actually, my target rotation. So my target rotation is 45 degrees, what we have computed. So this player will be moving here, 45 degrees rotation. Yeah, and that's basically it, guys. So that's how we computed step by step everything. I can close it, and let's go back to coding editors first, and you can stop execution. So simply you can just remove the breakpoint from here. You don't have any breakpoints any longer, and just play the game. So let's click here this continue execution. Now you can go back to your game in Unity, and you will see the player is rotated here, and you will see when you click on the player, the rotation is the 45 degrees on the y-axis, the exact rotation as we computed. So player is moving 45 degrees. And that's basically it. All right, now let's, okay, if you already understand this, you are free to go to the next lecture, but I will be talking about another condition here, okay? So just very quickly, this will be much quicker, okay? So I will clear it out here, make sure that your game is not running. Let's go to Visual Studio. And let's maintain here conditions. Let's say now the camera will be again 45 degrees, but the player will be not moving forward, but the player will be moving diagonal. So player will be pressing the forward key and the right key at the same time. So I'll write here a different condition. I will say here if the move input x is greater or equal to the 0.7 and move input y is equal 0 or the same as the 0.7, then we'll jump into the code here. I will clear this window, so right click, clear the window, right here the breakpoint here. Let's execute this. So, oh, it's still running, it should be working, but just in case I will stop it and I will run it again. All right, attach, and we'll go to Unity. In the Unity, okay, let me see. It will be reloaded. Your camera should be still in an angle of 45 degrees. Just verify it in the game window. You should be still facing 45 degrees. Let's go back to the scene. Let's place the game. And now, please, don't rotate anything. Just move the player. So just press the forward and the right key at the same time. Okay, I didn't jump into my debugger. Okay, interesting. 1 second, guys. I have maybe provided the wrong condition. All right, so let me see if they move. Oh, here should be Z. All right, my mistake, guys. Very big mistake. Here should be Z. All right, I will save this. I will again attach here. All right, so I'm attached. I can go back to Unity. I will run again, and I will be pressing only forward and the right key at the same time. So we'll run the game, press the forward and the right key at the same time. And now you can see the move input X and the Z is 0.7, 0.7. So my movement input is 0.7, 0.7. All right, now let's mark it down on the paper again. So let's see. Okay, so I'll go back here. All right, so the player can stay. This can stay the same. I can remove the parts what we don't need. Here we don't need. Here we don't need this. Okay, so now what's happening? All right, so the camera is rotated 45 degrees, but the player should be moving diagonal, right? So we are providing this direction here, diagonal. We are pressing the up key and the right key, so this vector should be 0.7, 0.7. All right, so a player wants to go now here, okay? It doesn't mean that it will go there, okay? So our move input is 0.7, 0.7, so this should be somewhere around here, 0.7 and 0.7, let's say here. Okay, so this will be resulting vector. I will mark it down here. So our move input is 0.7, 0.7. Okay, 0.7 and 0.7 is the move input now. Okay, let's go back to not do Unity, but the coding editor. So our move input is 0.7, 0.7 that we know. And now we are going to compute camera direction. So camera direction, again, forward vector multiplied by the 45 degrees around the y-axis. The value should be same, but let's write it down. All right, so let's write it here, camera direction. So we have a forward vector, and we would like to rotate this forward vector 45 degrees here. So this will be again 0.7, 0.7. Okay, so I can mark it down as well here. So 0.7, 0.7 somewhere here. All right, so mark it down here. The camera direction is also 45 degrees, which means vector 0.7, 0.7. All right, so now we know the camera direction. So camera direction should be same, 0.7, 0.7, as you can see it here, when I will hover over. And now we'll compute movement rotation. But in this case, movement rotation, in last lecture, we had a 0. In the previous example, we had a 0, but now they should be different. Because we are trying to look for a rotation of the forward to go to the move input, okay? So we have basically this. Here is our move input, but the forward vector is this vector, right? This is the forward vector. All right, this is a forward vector. So what's the rotation in between the forward vector and 0.7, 0.7? You already should know it. This rotation should be 45 degrees. So our move rotation now, previously we had a 0, but now move rotation is 45 degrees. Okay, we can prove it. So let's go back. Okay, so we can look here. So let's see, in the quaternion format is a 0, 0, 4, 0, 0, 9, but I will transform it. So let's get it to the intermediate window. You will see the rotation is 45 degrees around the y-axis. 44.9, there is a 45. Okay, so 45 degrees rotation is a movement rotation now. And now we are looking for a target rotation. So we are looking for a rotation, the camera direction 00707 multiplied by the 45 degrees. All right. So now the target rotation, we are saying here that we have this camera direction 0707 multiplied by the rotation of the 45 degrees. This means we need to rotate this another 45 degrees down, which will be exactly facing here. All right, so this will be my new rotation here. Okay, so that means rotation of 90 degrees because the camera direction 45 here plus 45 here, that's a 90 rotation. All right, so that now here I'm looking for a rotation here, camera direction multiplied by the move rotation is another 45 degrees. So I'm looking for a rotation of a 90. So the target rotation in the resulting target rotation will be 90 degrees. Because I will need to rotate my camera direction, which is 0, 7, 0, 7, another 45 degrees. This will be this here. This is the rotation of the 90 degrees. All right, so we can verify it. I can actually draw it already here. So that's the target rotation. So that's our final rotation of the player we will apply will be 90 degrees, which means the player will not go here as it intended 45 degrees, but the player will go in the end here, 90 degrees. All right, we can verify it. Okay, I can close this here, and you will see target rotation here is this 0, 0, 7, 0, 0, 7. We will put it here into intermediate, so clear. Target rotation will be 89.9 on the y direction. So this is 90 rotation of our player. We can verify it. We can just remove the breakpoint here, continue execution. So this arrow here. All right, let's go back to Unity. And now let's click on the player. So click on the player, and you can see when we are pressing up and the right, we are going exactly 90 rotation. And that's it, guys. So that's how this is computed, and you can see it written here on the paper. So how a rotation applied, how does it work basically? I know when you're looking at this first time, it can be difficult. I can completely understand. So you need to hear maybe more time, maybe you need to repeat some lectures, previous lectures, and you need to debug it by yourself. But now you have a very powerful tools. You have a debugger, you can use their intermediate, and you can see these values. All right, guys. So yeah, that should be it from this lecture. In next lecture, we'll continue and we'll be working on the new features because that was already enough of explanations. So guys, that should be it, and I hope to see you in the next lecture. Cheers.